Morning, guys. Today's session extends on the earlier session I did on visualization using large language model or AI. This one's a little bit, actually, a lot more advanced than the previous one. In contrast, the earlier one where I show how the AI is able to actually create queries based upon the schemas and the tools that we give it. This one actually does advanced statistics um, at the level of probably more advanced than what most typical company use. Um, the statistical tools that I created, it's the setup, rather, it's using Pandas, and it loads all the popular statistical and ML models or packages and tools. So basically, we're running an MCP server and we are providing that as a tool to the LLM to do its analysis. The setup is we're sourcing the data from SQL Server. Um, and for this demo, I'm using a Stack Overflow 2010 database. The size is not huge, but the size doesn't really matter because we're doing sampling and so forth. But this is to give you an idea what the volumes are working with. I've tried using Databricks with much higher volume. It's the same thing, it just takes a bit longer. I'll give you a demo as to what it actually does. So let me just run some queries. Now, I'm doing a lot of loggings at the moment because I'm troubleshooting and trying to understand the LLM thinking and so forth. So it runs a little bit slower. In production, you probably wouldn't need to log so much once things have been established. But I'll show you what the logs looks like because using LLMs, they do make mistake, and observability is a critical issue. So you need to be able to monitor those, especially during development. So here I'm just running a query, like I'm asking for some statistical analysis on the database that I just showed you in SQL Server. Um, this one here. So at the moment, that's the volumes there. It can handle much larger volumes, just like takes a little bit of a long time. I'll show you the architecture behind it. So at the moment, the user would run a query on it, and if you look at this one here, what's doing behind the scenes is the AI model is actually gone in there. It knows it's got tools to list what the tables looks like. So it's gone in and understand the table structures and so forth, the relationships and so forth, and based upon that, it's able to actually go and join the tables, find all the join all the tables using SQL and run queries. Yeah, and at the moment, it's just producing this graph to represent what it's looking, what the user has asked for, and it's just reasoning at the moment in the background. While that's happening, I'll quickly show you the logs that we're doing. So at the moment, up to 26 today, and basically it's actually gone in there. The MCP server started running SQL, running SQL queries in the back. Got the data. It's doing all these testings at the back, statistical analysis doing at the back. Now, where's a really interesting one? I'm still working on these logs here at the moment. So that on itself is actually a different another demo. But here, I actually have a kind of, might be easier if I try to look for it here. So it's going in there and it's running run SQL and job results. Here it is. So basically at the moment it's running some queries at the moment, right? And it could take a few seconds, could take a few minutes, could take many minutes. So basically what it's doing at the moment is in the MCP backend, we created a job because we don't know how long those SQL queries going to run. And basically the LLM is smart enough to go in there and poll for the results. So every few seconds, it will check. And if it takes too long, it'll come back and say it's still running. And um, and that we should probably wait, but that's not fun. So I optimized it and made it a little bit quicker. But if you were to try to connect to like a massive database in Databricks and so forth, then it will come back and say it's gonna take X number of minutes before we get the results. Do you want to go and talk about something else in the meantime? So yeah, that's a nice little trick that will overcome with long running process. So it's actually come back now and it's done the summary here. That's the statistics there. I validated the output using Gemini and LLM to make sure that we're doing things correctly because these statistics is outside my area of expertise, and it holds up. Okay, let's do a follow-up question now. Now we're gonna say this: the initial clustering of wells as well. Can you perform a following up analysis of the two clusters before calculating the average of upvotes and so forth? And now it's going to run a secondary query on in the back end. And now it's actually coming back and doing follow-ups. So it's coming back and it's producing a different one, yeah. Now the interesting bit here is I'm connecting it to the this front end that I built is in .NET ASP.NET. So basically, I built this front end. Now, because we created a MCP tool, we can use Claude Desktop and ask the same queries, and it will do the same thing. It's SQL, it's pulling up the data, it's coming back, check job status, so submit it, as I said, and then it's come back, the job has completed, and therefore it's able to go and do its thing and do its analysis, right? So, and this one here, okay, so I'm polling, I am running a profile against SQL databases, and basically it's just running queries against Python, and then you got all the queries at the back, so we can actually go and monitor the query that is running. But as noted earlier, we already got that information here in the Elastic, and it actually provides a lot more information than you would get with SQL Profiler. Now, the other thing that's probably worth showing is information that we've got. So at the moment, there's two things. Firstly, where um, for a application using AI, memory is really everything. So here, this is the memory that we've got in at the moment. And here, it's just to give it context so it can remember what it's done there. But the the main component or the data frame that it's doing its analysis is actually staying inside MCP server, which I can't show you. But that really needs to see that. So at the moment, this is what the memory in Redis looks like. What it's actually storing in there. And if I come in here and I say describe the data frame you have used in memory, including size of memory. So it's going to go and try to pull the stuff back from memory. Now you'll notice I'm asking for the data frame in memory. Therefore, unlike the earlier results where it was running queries against the SQL database, it's actually pulling it back. Describe loaded data is calling that tool and looking at the data frame, and it didn't have to run more queries. Now that would be extremely useful because if your queries loading into data frames from your source database takes many minutes, then that's a lot of time waiting. So at the moment, it's just loading it from the MCP data frame that's in memory, and it's just describing what it's found. And then here, let's say, let me have a look at what it looks like. Now at the moment, I've gave it quite a number of visuals. I think I've got a dozen or so visuals in there, and yeah. So basically, it's got charts, it's got whole bunch of statistical visuals that Python supports. And you can still add more and more advanced libraries. Um, and yeah, that's quite useful. And so at the moment, it's just pulling back 10 because if you try to pull a lot, it will consume a lot of memory and context window. So at the moment, we're just saying go and pull this back, and so you'll notice how fast it comes back because it's all from memory. And then finally, from our analysis, discovery, save your findings to the desktop in PDF format. Um, and it will do just that. Let me just sort it, and then Stack Overflow. So there you go. The key components, logging and observability. I have to admit, this is a still work in progress. Because while it's logging, I will need to refine it because it's logging on this initial development. It's still logging too much information, and I can certainly make this a lot more attractive. I'll probably use the ELK Stack or Cabana to create some fancy dashboard out of it, which will add a lot more value. But that's for another session. But yeah, so that's pretty much it. I mean, the statistic is pretty advanced, more advanced than most of the stuff that I've worked with the data analyst team and data science team, and yeah, so it can do a fair bit. Anyway, hope you enjoyed it. Yeah, wait for the next one, the logging and so forth. That will really give you the insight as to what it's actually doing behind the scenes, the reasoning for its decision, the really interesting bits. So stay tuned. There'll be more. Thanks for joining.